So let's talk about how skewness affects the mean and the median. We already know the definition of a symmetric distribution, a skewed left and a right skewed distribution. And we know that if a distribution is skewed, the median is going to be a better measure of center, whereas if the distribution is symmetric, we should probably choose the mean as the measure of center. So we have three pictures here that will help us to nicely remember how this works. For a right skewed distribution, the mean is larger than the median. The right skewed distribution is this one here. And so they've labeled for you the mean might be this one, and the median this one, and the mode is that one. The middle picture is the symmetric distribution. For a symmetric unimodal distribution, the mean, median, and mode are fairly close to one another, as shown in the picture. And this one is the left skewed distribution. For a left skewed distribution, we're going to have the median larger than the mean, and the mode larger than the median. So we'll do a couple of practice. Consider the accompanying distribution here. What can you say about the values of the mean, the median, and the mode? So this might be a good test question or a quiz question. Just from the picture, without knowing any of the numerical data, what can we say about the mean, the median, and the mode? Well, first of all, it's clearly not symmetric, and we have this long tail on the right, so this is a right skewed distribution. Since it's right skewed, we just have to remember then that we'll have mode less than median, less than mean. The next picture is also not symmetric, but this one has a long tail on the left, so this is a left skewed distribution. And so we'll remember that the mean is less than the median is less than the mode, median. Now here we have two dot plots, and it looks like they show the pulse rates for males and females. And these numbers should be the same in both charts. I'm just going to fill them in, even though we're supposed to assume that they're the same. The question is, without doing any calculation, what is your impression of which gender, if any, has the highest overall pulse rate? It looks like maybe the females have the highest overall pulse rate. The mode of the distribution for females is here, which is further to the right than the mode for the males. And it looks like in general there are more data points for the females over on this side. So maybe in general, the females. But without doing a little investigation, it might be a little hard to tell. So for part B, find the mean pulse rate for the males by estimating the location of the balance point. Then find the mean pulse rate for the females by estimating the location of the balance point. Well, let's look at the distribution for the males. First of all, for A, we're going to say maybe the females. Maybe. And then we're going to investigate. So let's look at the distribution for males. Can we say whether it's skewed left or skewed right? It looks maybe like it's left skewed. So here's our mode. We have the data kind of going long tail that way. So I'm thinking it's left skewed. But we want to find the median. Let's count how many data points there are. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20, 25, 65, I think. So if we wanted to find the median, there are 65 data points. So n is 65, n plus 1 over 2. So the 33rd data point should be our median. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 17, 18, 19, 20, 21, 22, 23, 26, 27, 28, 29, 30, 31, 32, 33. Okay? So 33, and it looks like our median is 73. And we already said our mode was 78. So this is definitely left skewed. As far as estimating the mean, we know that the mean should be even smaller than the median, so maybe 70. We probably could have picked 71, but let's say 70. And let's do the same assessment for the females. So we still know that there should be 65 data points. Let's double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 35, 53, 7. So I think that's correct. 65 females as well. And we're looking for the 33rd data point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 17, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. So that looks like it should be 76. Median is 76, and the mode is 79. So this is also left skewed. But if we wanted to estimate the mean in this case, I would probably go with 74. Or something around there. So then, does this agree with our earlier assumption? These estimates do agree. With the idea that maybe females have a higher pulse rate. Then it says the medians, find the median pulse rate for males. Well, we've already done that. The median is 73, we said, and 76 for females. So which gender has the higher median pulse rate? Again, the females. And that agrees with our initial assessment. Although I think initially it was a little bit hard to tell, and it's starting to look clearer and clearer because we see that the mean and the median and the mode are all reflecting this fact. Then find the following modes. Again, we have we had 78 for males and 79 for females. Right? And again, the females have the higher mode. And that does agree with our initial assessment.